Okay, 4.5. This is the last section that we're going to go over before your test. And I can't remember when your test is, but it's coming up next week. I'll be posting the review this weekend. And then early next week, I'll post the solutions in video form and document form um, so that you can hear me explain what I'm doing and how I do it. Okay? Now, so far, all we've learned is the power rule integral, and that's just a very basic x to the power type undoing of the derivative. Now we're going to learn how to undo a chain rule derivative. Okay, you had three types of chain rule derivatives. When you take the derivative of blob to the power, you multiplied by the power and subtracted 1 from the power. But don't forget that you have to chain rule that derivative of the u, the blob. It's all about the derivative of the blob when you're doing chain rule, whether you're going forward or backwards. So um, if you had e to the power, your power was u. The derivative was you copy e to the u exactly the way it was, and then you spit out the derivative of the power, right? It's all about the du. When you were taking the derivative of a logarithm, you put the function in the denominator, your blob is down below, and you put the derivative of the blob in the numerator. So if you can remember how to do these three derivatives, then you should remember how to undo them. Sometimes you don't have the necessary pieces to make a perfect du. So your job is to figure out what's missing and give it to yourself because your job is to create the perfect du. Now I want to stop here for a second because your textbook does this in a very mechanical way. Your textbook uses the u substitution and does a complete change of variable. I don't really want you to do that because it will make the next type of integral that you have to learn much, much harder. I want you to do it my way instead of the book way. Now, sometimes you have to do it. You have to go all the way and just change to a new variable to be able to do the integral, but you don't want to fall into the trap of doing all of them that way. And frankly, when I give you the example of a problem that you have to completely change the variable before you integrate, I'm not even going to do that the way the book does it. Um, so that's at the very end of this lecture. Um, okay, so tighten your belt, strap yourself in. It's going to be a bumpy ride until you get some practice under your belt. Um, but don't worry, you'll get it, okay? Remember, you only have three types of derivatives that you've learned that are chain rule derivatives. The power rule, the exponential problems, and the logarithms. So there's only three integrals that you have to learn. All right, let's get going. If I have the integral of blob to the power, I have to make sure that the derivative of the blob is in the question before I can take this integral. And I take the integral of blob to the power, as long as the du is there, the same way I did in the first section in the chapter when I was just adding 1 to the power and dividing by the power. So whatever the blob was, you copy it, you add 1 to the power, divide by the power, and you're done. Because as long as the du is in the problem, you don't care what u is. You're only integrating the outside of u. You're integrating what is being done to the u as long as the du is there. So your first job is to figure out what the u is, take its derivative to know what the du must be, and then you'll see in the examples, you do what you have to do to create the perfect du. Then you only worry about whether you have a power rule, an exponential, or a logarithm. And you just write down the answer. Okay, if your problem has a single e, the exponential integral is only valid if you have a single e, because the derivative of e to the power is another e to the power times the derivative of the power. So if you only have one e, the power must be u. I'm going to say that again. If your integral has a single e, you must set the power equal to u. So I say u equals whatever this is, I find its derivative, and this is the perfect derivative now of plain old e to the power. Your job is just to figure out what the du is and make sure it's perfect. And then you just copy the e to the u. You're going to have some weird coefficients in these problems because it's your job to figure out what's missing. Okay, the last type is the logarithm. If your integral is a fraction and the denominator has no power, then you make sure the top is a perfect derivative of the bottom and you have a logarithm. Now, if this u in the bottom has an exponent, like a square or even a square root, then that is actually a power rule integral. Got it? So if the bottom is just a polynomial and there's no exponent on it, no parentheses, then you most likely have a logarithm question. So you take the derivative of whatever's in the bottom, make sure that it's perfect in the top, and once you make this du perfect, you just write down your answer. Now, when you see some examples, this will make a lot more sense. So again, your job first, and I didn't list it, your first job is to figure out what type of integral you have. Is it a power rule? Is it an exponential? Is it a logarithm? Most of the problems, you should be able to figure that out just by looking at it. Process of elimination works great because the exponential ones are very obvious. The logarithms, there's going to be lots of times where you have a fraction in your integrand, but the denominator has an exponent. So, watch out. At the end of this, I'll show you some exceptions, but most problems will follow these rules very cleanly. Okay, so the first step is to figure out what kind it is, and once you know what type you have, then you can figure out what u is. Is u the denominator and I have a logarithm? Is u the exponent on e, so I have an exponential? Or is u the stuff inside the parentheses? So that's all there is to it. Once you figure out what your u is, you take the derivative of it, and then you look to make sure you have all the pieces that are necessary. You create the complete and perfect du by multiplying by constants, only constants, and you multiply actually by 1. So to create these perfect du's, you're going to multiply by whatever's necessary, but you multiply by it and then you divide by it so that you're actually only multiplying by 1. Then once you've done that and you've created the perfect du, then you can do the integral, and that just means you're undoing the derivative. So, first problem, x times the square root of the blob. Now, you see that you have a function inside some operator here. This square root is just an exponent. It's a 1/2 power. So when I rewrite my question, I've got blob to the power, and all the rest of it is x dx. Now, I set the inside of the parentheses. I know this is a power rule, so the inside of the parentheses is my u. Write it down. This is your cheater box here. You've got this stuff over here to tell you what you're doing. So in my cheater box, I said u is the stuff in the parentheses. Now, to find du, I don't look at the question. I look at what u is. If I'm taking the derivative of this equation right here, the derivative of u is 2x plus nothing else. So I get 2x dx. Well, now look at your question. In the question, you had blob to the power, and then you had x dx. Well, you see this x dx in your du. The only part missing is the 2. So I have the 2 is missing, and so I'm going to multiply by 2 over 2. When I multiply by 2 over 2, I'm going to take that top guy and multiply him right here to give myself 2x dx. The bottom 2 that I multiply by is going to stay on the outside. Multiplication on the outside by a constant is just multiplication on the outside by a constant. That's all there is to it. But I need to use this 2 to create the perfect du. Do you see it? I took the 2 from the top, I stuck it on the inside to make my du, left the other 2 that was in the denominator, left that on the outside. That's just going to be a coefficient of my answer. Now what am I left with? I have my original u to the power, and now I have a perfect du. So the only thing I'm integrating is blob to the half because I have the derivative of the blob. Once you have that perfect derivative, you don't care what the blob is. You're just integrating the fact that it's raised to a power. So what do? I add 1 to the 1/2, and I get the 3/2. Add 1 to the power, divide by the power. The 1/2 stayed on the outside, and now I just make it pretty. Dividing by a fraction means I'm going to flip the 2 to the top. The 3 stays on the bottom. The 2 on the top cancels the 1/2 from the outside, and I'm left with just a 3 on the bottom. Okay? Just add 1 to the power, divide by the power, and then make it pretty. Once you get the perfect du, you don't care what u is, you're only integrating the outside. Okay, an example of an exponential. I think you did these in the previous section, but I believe this is a perfect chain rule derivative, so it should be in this integration section. So just my opinion, but okay. So you see in this integral that we have a single e. That means that you must set u equal to the exponent. So in my little cheater box here, u equals the power. Take the derivative of that. You see I only need a -3 in front of the dx. All I have is dx. So what I'm going to multiply by is the missing piece over itself. This means I'm multiplying by 1. But when I multiply by that 1, the -3x that's missing in my du is going to go in and multiply and give me perfect du on the inside, while the -3 in the denominator stays outside and is now my coefficient. And the integral of e to the u, perfect du, is just e to the u. Okay, in this problem, you see you have a ratio, a fraction, but there is no power in the denominator. So it's not a power rule. You're going to, this has to be a logarithm. You know it by looking at it. So because it's a logarithm, you set the bottom equal to u. Take the derivative of this, you need 2x dx. you see that the x dx is in your question. You're just missing the 2, right? So you multiply by 2 over 2, but the top 2 goes inside to make the perfect du, while the bottom 2 stays on the outside. And now this is actually what I'm integrating. I have the function in the bottom, the derivative of the function on the top, with that little adjustment on the outside. So the integral of du over u is just the ln of u with my adjustment. Okay, next problem, kind of the same thing. We have a function in the denominator with no power. That makes this a logarithm. Set the bottom equal to u, take its derivative. I'm missing the 3. All I have is the dx. So I'm going to multiply by the 3, divide by the 3. I only multiplied by 1. I did not change the value of anything. But now I have du over u, which is just the ln of the bottom. And the 1/3 is hanging out on the porch. He's just my coefficient now. Next, a single e in my question means that I have e to the u and a du. I need the du. So you set the u, the exponent, equal to u, take the derivative. I have dx, but I need the 2. So I multiply by 2 and I divide by 2. That gives me e to the u du. Integrate that, I just get e to the u with that coefficient on the outside. By the way, when we get to where we're doing this a lot, and you'll have e to the power a lot, you'll see that I like to write e to the 2x divided by 2. And I think we've done that before, right? Next problem. This is really important. You see that we have a fraction, but notice that the denominator actually has an exponent. Radicals are exponents. And remember, the top is the power, the bottom is the root. So this is just blob to the 1/2. So I rewrite over here as blob to the minus 1/2, minus because it's in the bottom, 1/2 because it's a square root. Now, I set the stuff inside the parentheses equal to u. Find the derivative. Now the derivative of x squared plus 2x plus 3 is 2x plus 2. I don't have 2x plus 2. I only have x plus 1. So what I did was I factored the 2 out of this, and there's my x plus 1. So I have the x plus 1 in the dx. I'm missing a 2. I multiply by 2 where it's needed, and I divide by 2 so that I haven't changed the value. I just multiplied by 1. So now I have u to the minus 1/2 and a perfect du. So what I'm going to do is I'm going to add 1 to the minus 1/2. It gives me plus 1/2, which is just a square root in the numerator. And I'm going to divide by the new power. Well, when I divide this whole thing by 1/2, this guy on the outside cancels out, and I have no more coefficient. Sorry, I ran out of room, so that's why I did it that way. Okay, now I want to demonstrate one that you kind of have to go all the way. Sorry, black pen. You kind of have to go all the way and change all of the variables. Let's try x over x minus 1 dx. Now, this looks like a logarithm, right? Because you have a denominator with no power. So what I would try first is setting the bottom equal to u, find the derivative, and I just get dx. Well, here's my dx, but the problem is that I have an x here. If that was just a number, I could factor it out, but it's not a number. I can't do anything with the x. I can only multiply and divide by constants. So I have a problem here. And when I run into this is oh no, I've got too much stuff problem. When you run into an oh no, I've got too much stuff problem, you're either going to have to do integration by parts, which is on the next test. It's 4.6, I think. So we're not going to worry about that until we get this stuff down and take a test on it. Or you're going to do what I'm about to show you. Now look at my cheater box. I already have chosen you to be my denominator, not you personally. But I have this x here, and the only way that I can get rid of it is to change it into something else. And I already know that u equals x minus 1. So if I take this equation right here and I add 1 to both sides of that equation, then what I have is that u plus 1 equals x. Now look at my equation here. I'm going to cheat it just a little bit so you can see what's going on. The dx, I've already solved that. That's du. So this is du. I'll write it out nice and neat in a second. I said in my cheater box that the x minus 1 equals u. So this is u in the denominator, not you personally. And I said that the x in the numerator was u plus 1. So I'm just going to rewrite this integral and change all of my variables to u's. Now I can just integrate with respect to u instead of respect to x. By the way, what I just said, whatever the variable is here in your d, your differential piece, that's the variable that you are integrating with respect to. If I integrate a 1, I'm going to get u, not x. Okay, so watch out. Now, in this case, what I've done by getting a single term in my denominator, now I can say that everybody in the numerator is being divided by that term in the denominator, or factor in the denominator, and I can rewrite again saying that u divided by u is 1, and then I have plus 1 divided by u, 1 over u, and du is just du. Now I'm going to integrate this term by term. So first I integrate 1 with respect to u, and that gives me u. And the next term, I've got 1 over u times du. Well, what is that the derivative of? If my u is in the denominator and I'm multiplying by the derivative of that, this is a logarithm. So the second term is plus the ln of u plus c. And now I have to go back and replace the u's with what they equaled in terms of x's. Now u was equal to x minus 1, so I have x minus 1 plus ln of u plus c. Now I'm going to make this a c1 because sometimes we'll do these problems in different ways and get different answers, but really because this c is some unknown constant, I can take that minus 1, shove it in there, and get that an equivalent way to write this answer is, I'm sorry, I didn't replace that u. Hold the phone here. Let's not make the same mistakes as the teacher, okay? If I'm going back to my x's, this is x minus 1, and this is x minus 1 plus some constant. And you see I'm using the 1 and the, you don't have to do this. I used the 1 and the 2 to show you that it's still a constant. I've just changed it by a little bit. And that is that. Not too bad, huh? Another example here. Let's say that I have, hold on, black ink. The integral of 3x over the square root of, no, hold the phone. I'm sorry, I'm making it, it's just like being in class, isn't it? Keep changing my mind and making mistakes. Let's say 4 minus x squared, just to make it interesting here. So you see that what you have is a power rule. 4 minus x squared is on the bottom, so it's a negative power, and it's a root, so it's to the minus 1/2. And then that 3, this is why I wanted to do this problem. That 3 that's multiplying can be factored out and be seen as just a coefficient. And now that the rest of what's in the question, I have all of this, I've changed that to blob to the power. I pulled the 3 out, now I'm left with an x and a dx. So the next step, I know what u is. U is going to be the stuff in the parentheses. So u is 4 minus x squared. Take the derivative of that. I'm going to get negative 2x dx. Pay attention to your signs. They're very important. Okay? So what's missing? I've got x dx right here. I'm missing a negative 2. So what I'm going to do in the next step is I'm going to take my integral here, blob to the minus 1/2 x dx, and I'm going to multiply by the missing minus 2, and I'm going to divide by a minus 2. Do you see that I did not change the value of my integral? I just multiplied by 1. So now I have negative 3/2 on the outside, and my integral is u to the minus 1/2 and a perfect du. Once you have the perfect du, you don't care what the u is. You're just going to copy it. You're going to add 1 to the power and divide by the power. Now that guy in the bottom, 1 over 2, is going to flip to be 2 over 1. The 2's will cancel, and my final answer here is going to be minus 3 square root of the stuff plus c. Now, some of you, while you're watching some of these, have said, what happened to all the stuff? Where did all this junk go when you got your answer? Well, this is the stuff that got spit out when you did the derivative of the inside. When the derivative was taken, you multiplied by the power, you subtracted 1 from the power, and then you went bleh, you spit out the derivative of this stuff in the parentheses. Well, if you're going backwards, then all of this stuff is going to get sucked back in. I know it sounds gross, doesn't it? But that's what's happening. All of this stuff is used in the process of undoing the derivative. So it gets sucked back in. He's long gone. And the best way for you to understand all of your integral problems, no matter what kind they are, is to take this answer. I'm telling you, take the time to do this. Take this answer, take the derivative of it, simplify it, and you'll see where all this stuff in the original problem came from. You'll see that your derivative is this perfect beginning question. So the best way to learn how to take an integral is to take the derivative. When you're done, it will solidify what you're learning, and it will build your confidence so that you can just keep moving on and doing the other problems. Okay, I know this was a long video, but to finalize it, you remember you've only got 3 types of chain rules that you've learned, and therefore you only have 3 types of integrals by substitution that you need to worry about. You have an exponential, you have a power rule, and you have a logarithm. And the first thing that you need to do when you open up the homework is just go problem by problem and say, that's a power rule, that's a logarithm, that's an exponential. Go down the whole row, just looking at them without writing anything down. Just look at them and see if you can figure out exactly what kind of integral they're going to be. Once you figure out that you have a power rule or an exponential or whatever it is, you're going to choose the U. If it's a power rule, U is the stuff in the blob. If it's an exponential, there's only one E in your problem, then U is the exponent. If you have a fraction and there's no power in the denominator, then the denominator is U. Once you've picked U and you always write it down, then you take the derivative of the thing that you chose. Don't look at the question, only look at your little cheater box. You picked your U, now take the derivative of it. At that point, you're going to compare the du that you need with the stuff that's in the question and figure out what's missing. Once you figure out, and it has to be just a number, if there's an x or some function that's missing, then you've done something wrong, okay? You can only multiply by constants. But once you figure out the missing constant in the problem that you need to create a perfect du, then you're going to multiply by 1. If I need a 2, I'm going to multiply by 2 and divide by 2. The thing I multiply by almost always is the one that goes on the inside. The thing that I divide by is on the outside. And he becomes the coefficient of your final answer. Once you create the perfect du, you're ready to integrate. And remember, these are the only 3 that you need to remember. And I just thought of something that I need to show you. It's the 2 cases where you have something in your denominator that is not the u. Okay, so one more page. I'm sorry, guys. Okay, a couple of exceptional type things. Let's say that I had a problem, e to the square root of x over the square root of x. Something that you need to remember, if you see a root x in your denominator, if there's a root x anywhere else in your problem, in this case it's right here, this guy in the denominator is the derivative. I'll say that again. If you have a root of x in the denominator, this guy is the derivative of the other guy, okay? So let's rewrite this integral in a way that we can really see what's going on. We have a single e to the power. That has to be e to the u. You have no other choice because e to the power is the derivative of itself. So if you had a power rule or a logarithm, there would have to be a second e in the question. So I'm forced to make that power the u. All right, so I've got my e to the power written down. You see the rest of the problem here is a root in the denominator and a dx. So what I have is 1 over the square root of x times dx. Now let's figure out what we got going here. Because of the single e, we know that u is the power. Well, that's just x to the half. Take the derivative of that. I'm going to multiply by 1/2. I'm going to subtract 1 from the power, which makes that a minus 1/2. And don't forget the dx. And seriously, don't forget the dx. Now, what does this look like algebraically? I have a 1 in the numerator. I have a 2 in the denominator, and that negative exponent is going to take the x to the bottom, and it's a square root in the denominator. Do you see where I'm going with this? That square root of x in the denominator here is right here in your question. The only thing that's missing is the 2, and notice that that 2 is in the denominator. So what you're going to do is you're going to take what you had, you're going to take what you had, e to the power. I have a root of x in the denominator and a dx. I'm missing a 2 in the bottom. Let me do that the way I was doing in blue. I have the 2 root x in the denominator, but because that 2's in the bottom, now I get a 2 on the top, on the outside. So you see, all I multiplied by was 2 over 2, which equals 1. I did not change any of these values. So what I've done here, now I've got a coefficient, I have e to the power, and I have the perfect derivative of the power. So my answer is just 2e to the root x plus c. Got it? Good. Okay, one last very important thing for you to remember is that if you have a logarithm, if there is an ln of something in the integral, it must be the u, or at least a part of the u. Okay, now watch this problem. Let's say that I have the ln of x over x dx. It looks like a logarithm because what was the rule? We had something in the denominator that didn't have a power. But in this case, this x is part of the du, because if you have an ln in your problem, it must be the u. So now when I choose my u, I have to make that the ln. Take the derivative of that. Look at that. There's an x in the denominator. So if I rewrite my problem as the ln of x times everything else in the question, I have 1 over x dx. Well, guess what? That is my perfect du right there. So I've got this guy is u, and this guy is du. How in the world do you integrate u du? Well, over here in my little thought bubble, how do you integrate x dx? Well, you just make it x squared over 2, right? Well, this is the same thing. We're integrating u du, so we're just going to integrate it the same way that we would if we had x dx, and we're going to add 1 to the power, divide by the power, plus c. Remember at the very beginning, I told you that as long as you have the du, you don't care what the u is. You're just integrating what's happening to the u. So what we have in our parentheses here just happens to be ln of x. If you take the derivative of this answer, that 2 in the denominator is just going along for the ride. You're going to bring this 2 down and subtract 1 from it, and the 2's will cancel. You'll just get the ln of x, but you've got to multiply by the derivative of this stuff in the parentheses here. So you'd be multiplying by 1 over x, and look what you'd have. ln of x to the 1 over x. Do you see how it works? Okay, I know you're going to have tons of questions. This is probably the hardest thing that we've done this semester, and not being able to be face-to-face makes it a little bit harder on top of that. So, over the next few days, watch for another video where I'm just giving you more examples. You need to try them. If I've got 5 other classes that I have to post for. So try this homework, and then the extra video should give you some extra help. And please, 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 I beg you, if you need to get with me and ask me questions, use the texting, not the email. The email is too slow. Some emails are taking up to 12 hours to get through, especially if they're sent through Canvas. So if you're going to email me, don't use Canvas, email me directly, but I would very much prefer that you text me because I get it instantly. You text me, and if you need to really talk, we'll just jump on Zoom real quick and we will bang this stuff out. And please, please don't struggle. Always ask me for help, okay?